Hello guys, welcome back to my channel Mason African Motives on A-level mathematics, that is pure math, which is a continuation from our previous class working on trigonometry for the lower part, that is the lower 5. Yeah, just trigonometry guys. Okay, so this is our second class that we are going to have, and having a continuation from our previous class where I actually had an introduction of the angles, the special angles and so forth that we worked on. And we are going to just like work from there, like from those special angles. So I hope you are going to understand me guys in a much way. So now we are going to move on the application now of the angles that we had. Remember, on our previous class we worked with the application of special angles. Okay, application of special angles. This is what we had of the angle for 30 degrees, the angle of 45 degrees, the angle of 60 degrees, and the angle of what? Of 90 degrees, which are actually from our right angled triangle concept, where we are going to see this. And I'm going to just show you like a glimpse of what was happening. Maybe you can understand from the introduction that we had. We have some of the copies here where I introduced these special angles. Remember guys, one for 45 degrees and so forth. And also I have got another recap also that I talked about from 60 degrees and 30 degrees, the one that I had to subdivide into two like this. So remember, I had to subdivide this into two, into a separate triangle like that. And also, so there are so many things that we talked about, the identities themselves, like the first part, the application of the quadrants, and also the ratios that we are going to work on. So actually we talked about this in our previous class, so just watch so that you can be able to understand all the explanations that was happening. Now we are going to work with our special triangles, but in application now. In application. So we want to see how are we going to apply these special angles, especially with this special type of an identity which you'll be given in your formula sheet, which is the compound angle identities. So I'm going to work with the compound angle identities much in this class. Compound angle identities. All right, so what do we have on this type of identity, which is the compound angle identities? Okay, like I said, these are identities. Really, I'm not like proving these identities, I'm using the identities. So I'm just going to write them down and show you how are you going to use these identities, where you're given cos A plus or minus B, which is equivalent to, this is going to be cos A, cos B, and you interchange when it's a cos, so it will be minus plus. All right, minus plus, you just interchange, and that's sine, which is sine A cos A, sine A sine, sorry, sine A sine, which is sine B in this case. All right, so it's sine A sine B, cos A cos B. So just like that, like you just interchange this part, and which is the same thing. Actually, I thought I'm working with sign, because like always when I write these identities, I start by writing sign, you see. So that is why now I was like, okay, anyways, it's fine. So when it is sign like this, it is going to be sine cos, so that will be sine A, and that will be cos B like this. And for sine, these signs will just remain in the order as they are, but this time you can write as cos. Now you can start with cos, so it will be cos A cos, then it will be sine B. All right, like that. So this is like the concept that you just have. And for tan, so you just need to memorize these identities. That's going to be much better for you. And for tan, it is going to be given by tan A, and that's plus or minus again tan B. All right, but now it is going to interchange here. When you introduce one, it will be minus plus now. Okay, then it will be product of the two, that's tan A and tan B. And like I said, compound angle identities, these are the identities that we are just going to at least focus on, and just know what's happening here. Like there are simplifications guys of some other questions, like and they'll strictly say do not use a calculator, and you'll be like, what? don't use a calculator. How is that possible? Like, how is this possible? Like, how? All right, like this part. You're asked to simplify maybe a cos 15 degrees. Okay, without using a calculator in that, just simplify cos 15. And you'll be like, how am I going to do this? Okay, so you're going to connect the dots between the angles that you have got here, the angle A and the angle B, because you want to create two angles to give you a single, because the moment you subtract or add, you are going to have a single angle like what happened here. It means here either we were adding or you were subtracting, but what happened is that you ended up with a single number which is 15, a single number which is 15. So the question is, where did I obtain this single number from? Now, that's the introduction of our special angles. Remember, our 30, our 45, our 60, 90 degrees. So my question is, it's supposed to be under addition or subtraction in order for me to obtain this 15. So it's either I'm asking if I add or if I subtract, but I'm going to clearly see that these two, they can play around something. If I subtract this, that's cos 45 degrees minus 30 degrees like this, I'm going to achieve, or I'm going to have this cos 15 degrees. That is what I'm going to have in this case if I do so. So that means it's now an advantage. Why? Because cos 45, I mean 45 and 30, they are there on our special triangles. So the thing is, yes, I've got 45 and 30, but what am I going to do? Remember, I've got an identity here. This time I'm going to focus with cos A minus B minus. So remember, when it is a minus from this part here, when it is a minus here, it is going to change into a plus. Minus and plus, it corresponds, it changes. When it is a plus, it changes to minus. So it is going to be plus because it was a minus. But as you can see, it's cos A, cos B, which is, this is your A and this is your B. So when you say cos A, cos B, it's cos 45, cos 30. Okay, don't use the sign, just as it is. Okay, so it's going to be cos 45 degrees, cos 30 degrees. Don't use the sign to say cos minus 30. No. The sign already is used in the identity itself. So minus changes to a plus and it becomes sine A, sine B. So it is going to be a plus. Now it's sine A, which is sine 45, sine 30 degrees, like that. The moment you are able to write like this, then it's now you and your special angles, guys. And from our special angles, we've got cos 45. I think I explained these ones before. So under exam condition, like you'll be like stuck to say, okay, I'm at this stage and I don't know the value of cos 45. What am I going to do? Guys, you can even, okay, this one is for 60. I just want to bring those triangles, guys. I don't want to like sketch this again. You'll be like, I don't know this value. You can even use a calculator, because what is important, what the question is simply avoiding you to do, is to, at this stage, to just use your calculator direct. Because if you use a calculator, it is going to give you an answer, but that answer is not going to be valid because they said without using a calculator. Okay, so this is what you're going to take now. Cos 45 degrees. I'm just going to take this as cos 45. Remember, we said cos 45 is what? Adjacent over hypotenuse, and we got 1 over square root of 2, which gave us square root of 2. Remember, square root of 2 over 2 here. So this one is going to give us square root of 2 over 2 times cos 30. Here we do not have 30, so I have to use the triangle that has got 30, which is this triangle. And cos 30, we said it's adjacent over hypotenuse, which gave us square root of 3 over 3. So it's going to be square root of 3 over 2, not 3, guys. Okay, plus now sine 45. I have to go back that triangle, but remember I told you that sine and cos are the same. Sine 45, cos 45 are the same, and it's going to be square root of 3, square root of 2 over 3, square root of 2 over 2, not 3. Where am I getting the 3 from? This one? Okay, no, I'm just having this 3 in mind. I don't know where actually it's coming from. And the sine 30, here I have to go back to the triangle that has got 80 degrees, and some of these ones you must even know them by head, guys. A level, you must know this one, sine 30, that is just a half, and you must just know this by head, some of these ones. Okay, I'm not saying if you don't know them it's wrong. No. I'm not saying, just say you must know. It can help us a lot if we have got something like that. Okay, the other further thing is to simplify. So now I can multiply from my application of sets. Remember, sets, you can multiply numbers under the square root. As 2 times 3, which is 6. Over here we can multiply 2 times 2, because these ones, they're outside of the square root, so they can be multiplied. And never be tempted to reduce these two. They can't be reduced. Just leave it like that. Plus 2 times this is just like 1 times any number, it remains as, even 1 times x remains as x. So 1 times square root of 2 remains as square root of 2. Then we can multiply 2 times 2, which is 4 in this case. So as we know, guys, if the denominators are the same, you can easily combine the two. The square root of 6 plus square root of 2, everything over 4. The denominators are the same, so just combine, just like 1 over x plus 3 over x. Just add. This one is 4 over x. Don't think a lot. The denominators are the same. Just add the numerators. You're done. So these are the typical questions that you have got there that you're going to at least work on, and you see how these guys are asking these questions. So like I said, guys, that's an application. So I just want you to try as much questions here. I'm just having like questions that I want you to try. The question will be, without using a calculator or tables, find the value of the following. You're given the values there: cos 40, cos 15, sine 50. Okay, so those ones I've written the answer so that you can just try, and some others I didn't like write because I want you to actually try what's happening there. It's not like, guys, I'm supposed to just give you all the answers, like all the answers as they are. No, try and see. If it is not working, then we come back and we talk in our next class. So that is the first part that we have got this. So I'm just going to maybe just take you 1 or 2 maybe to make a simpler, but I want you to try these questions. Can we just maybe see this one, question number 2? All right, on question number 2, I'm having sine 150. So where am I going to have sine 150 from? That is the question. Where am I going to have sine 150 from? 150 from our angles. Now I have kept that paper away again. Okay, see here, because I just want to use this part because we wrote this once before, guys. So where can we have 150 from? From these two. If these two angles are added, 60 and 90, I'm seeing something that can work there. So this is going to be like sine 60 degrees plus 90 degrees. That is what it means. All right, so if it means sine 90 plus 60, then where is the ratio for sine? Which means we need the ratio for sine. And remember, sine, when it is adding, it is going to be like this. This will be your A here, and this will be your B. So remember, sine A plus B is going to give us sine A cos A plus sine. When it's a plus, it remains as plus, and it's going to be cos this time. Or you can even write this with the sine. It's one and the same thing, but if you start with cos, it will be cos this A. So it's cos A sine what? Sine B, like that. Okay, so what does this mean? It means from this part that we are talking of here. Okay, so this one is not part of our working, guys. Okay, so this is going to be sine A, which is sine 60. So we've got sine 60 degrees, cos B, which is cos 90 degrees, plus cos A, which is cos 60 degrees, sine 90 degrees. All right, so this is what you're going to have. Cos 60, you go back to your triangles, those triangles, guys, and you find a normal ratio. Okay, this one, let me just use this one here. That's our sine 60 here. We said gonna be square root of opposite over hypotenuse, use square root of 3 over 2. So this will give us square root of 3 over 2 times cos 90, guys. Actually, cos 90, when we're not even supposed to take this, because we know that cos 90 is equal to 0. It's not on our table, but you're supposed to know that cos 90 is 0. And even here, we can even use a calculator here. Plus, but you're supposed to know, guys, cos 90 is a 0, sine 90 is a 1. Okay, what about cos 60? Cos 60, that's adjacent over hypotenuse, which is a half. So it's going to give us a half times sine 90, which is a 1. So that will be a 0 plus half times 1, which is a half. So this will be us a half in this case, which is 1 over 2. So this is the value for sine 150 degrees. So I want you to use your calculator and see if you are going to obtain the same thing as 1 over 2 for sine 150. If so, then that means what we are saying here is actually true. So that's how these guys play around our minds, guys, in exam, and they'll be like, what is happening here? Okay, what about this tan 75? I think some of these ones we can even try as much as we can. You can even try to do even much better than what I'm doing here. So this is tan 75. So all we need is to locate our tan, okay, our angle, sorry, of 75 from those angles. And we said 75, you can actually take 35, 30 and 45. Yeah, these two can actually play around something. Okay, so that means this tan 75 degrees is equivalent. I don't know which one are you going to start with. You're going to start with 45 or with it, I don't know, but this will be equivalent to tan 45 degrees plus 30 degrees. If I add these two, they must give me this value. And tan, remember from your identities, tan, if it is tan A plus B, like this. Okay, I wasn't supposed to write it here. Okay, so if it is A and this is B, okay, supposed to give you tan A plus tan B. So this is tan A plus tan B all over 1 minus tan A tan B. Okay, so take note, if it is a plus, guys, you add on top the tan and the tan, down you subtract. So this is your A, this is your B. So it simply means this is going to be tan 45 like this, tan 45 plus tan 30. That is what it means. Okay, everything over 1 minus tan A, which is tan 45. So it's tan 45 times tan 30, which is your tan B. So here you multiply. That is the case there. You just you have to multiply your values, and from there you can simplify as much as you can. How are you going to simplify? Like because like you cross check just your answers, they can be under a square root, they can be exact. So all you need is to substitute those values. And tan 45, we talked about this. We say tan 45 is actually equal to 1 here, opposite of adjacent, that's a 1. So tan 45 is actually equal to 1 plus tan 30. So we have to go back to our triangle where we've got tan 30 there, and you saw that actually when it is 30, it's opposite of which is 1 over square root of 3, and 1 over square root of 3 ended up giving us square root of 3 over 3. So this is a square root of 3 over 3 like this, everything over 1 minus tan 45 again. This is 1, so it's just 1 times tan 30, and tan 30 is square root of 3 over 3 again, like that. All right, so which means there are some magics that we have to play. And which magic can we play? Okay, let's just try and play our magics aside here. Let's just add these two aside. 1 plus square root of 3 over 3. This simply means you can add, and 1 you can just put it as a fraction, like 1 as a fraction. You can just write it as what? 3 over 3, isn't it? 3 over 3 plus square root of 3 over 3. Since here the denominator is what? Is 3, so you can write this as 3 over 3. Suppose 3 over 3 is 1. So why writing this? Because I know that I can easily add, because the denominators what are the same. So it's simply over 3. So I can add 3 plus square root of 3. So it's 3 plus square root of 3. So this is what I am obtaining in the numerator here, okay, which is 3. Is it going to be fine here? Let's just write and see. 3 plus square root of 3 over 3 like this. So let us just put it in a bracket like this, everything over 1 minus square root. So as you can see, it's just like the same, because it was 1 plus. So when it is a minus, it's just going to be 3 minus, because you're going to do the same thing. 3 over 3 minus the square root of 3 over 3, because 3 over 3 is 1, and 3 minus square root of 3 simply means 3 minus square root of 3 over 3, because we can't like simplify this. So we are going to have 3 minus square root of 3 everything over 3 like this. So this is what you're going to have from this, and this is like just your normal normal division, guys, like x over y divide by maybe m over, you guys, you know your division. So introduce your multiplication, invert the second fraction. So just simply this part as it is, 3 plus the square root of 3 over 3, you just write it as it is. Remember, this simply means division. This one, you are dividing. So if you are dividing, you introduce multiplication and invert the second fraction. So it's going to be 3 on top now. So it will be times 3 on top over the this one, your numerator now, as your denominator, which is 3 minus square root of 3. And by doing so, this can cancel. By just doing so, those two can actually cancel, and this is just 1 over 1, and I can multiply this times 1, which is 3 plus square root of 3 over 3 minus. Guys, I'm not in a SEDS. I'm working on trig. These are another separate topic that you're supposed to know its principles as they are, which is on what on SEDS. So these are the typical questions, guys, that you're going to work on and revise on. So that's what I advise you to do, and to revise and as much questions as possible. And this one, it was like maybe you try those questions, but this one I was like, what's happening here, where we are given something like sine 20, and someone will be wondering, where is this 20 coming from? Guys, don't do that. Okay, like you're in an exam and you given something like that, where you have got something like this. This is it. This is number 8, which is sine 120 degrees. How is that possible? Where am I going to have this from? All right, simply from those angles, I'm going to see that we do not have a condition like where I'm going to have different angles that I'm going to use. Okay, this is what I have, guys, from the angles here. Like I do not have, if I add this, yes, I can add 90 and 30, which is 20, but 90 and 30, okay, let's just use this 90 plus 30, because most of us, that's what we want. 90 plus 30 simply gives us what? Simply gives us 120 degrees in that format. But someone can use this. I'm going to work this separately, all the two. All right, so sine 120 degrees in this case is going to give us sine 90 plus 30, which is 90 degrees plus 30 degrees. So this simply means we can even do it like this: sine 120, which is sine 60 plus sine 60. Am I wrong, guys, to write sine 60 plus sine 60? It's just one and the same thing. As long as you're applying the exact thing, it must give us the exact answer for these two. So here, this is your A, this is your B. So remember, sine is going to be sine A cos B plus cos A sine what? Sine B. So that's sine 90 degrees I cos B, which is cos 30, okay, plus cos A, which is cos 90 degrees by sine B, which is sine 30 degrees. Okay, sine 90, we talked about this. We said this is 1 times cos 30. Back to our diagram again. We have to substitute our cos 30, guys, and those diagrams. Now you see I'm having a lot of things here. Actually, that's what you have here from our cos 30, guys, which is square root of 3 over 2. So it's going to be square root of 3 over 2 plus, and I talked about cos 90, that says 0. So whatever that you're going to have multiplied by 0, guys, says 0. So this is square, but it was sine 30, which was actually what? A half. If you want it right, it's 0 times half, and you add 1 times square root of 3 over 2, which is actually square root of 3 over 2. So as you can see, that's what you're going to have. And maybe I didn't see this like in exam, and I'm stuck like the angles. I just seen 60 and 60. I'm going to apply the same thing. So as you can see, to be A and B, just like that, and you're gonna have sine and you be like that. So which means this one is going to give us okay, let me just put it from this one. So it will be just like this: sine 60 degrees now. So it will be sine 60 cos, which is cos 60 degrees, plus cos 60 degrees sine 60 degrees. So as you can see, it will be just like 60, like it's a repetition of what is happening. And it's like 1 sine 60 plus 1 sine 60. So if I add 1 plus 1 is simply what? 2, because this is the same cos and cos, sine and sine. So it's 2 sine 60 degrees cos 60 degrees. And this is going to give us 2 times sine 60. We now go back to our triangle and locate our sine 60, and you see that your sine 60 here is the opposite of which is square root of 3 over what? Square root of 3 over 2. So that's what you're going to take, which is square root of 3 over 2 times cos 60. And we said cos 60 adjacent over hypotenuse, which is 1 over 2. So by just having this, I must have the same answer. So it's not like it's a one-way thing. I have to take this way or this way, guys. No. It's not like that. So you can cancel this. Square root of this, square root of 3 times 1, which is square root of 3 over. This is 1, 2 times 1, which is simply a 2. So it's going to be square root of 3 over a 2 like that. So that's how you are supposed to try this question. So guys, I want you to work as much questions as possible. When we shall meet again, we shall work as continuation from other areas, identities. There are a lot of things that we have got on this particular subject on trigonometry. We've got a lot of things that we have, and we are just going to work on this and also adding from another perspective, that is from another area or from another topic, so that we don't like consume much time on this single topic, because there are a lot of things that we need to cover before exams. So that's it, guys, from African Motives. Till we meet again.